Good day guys, welcome to today's video. In today's video we are going to talk about something important. Today's video is about millis function. But before I talk about millis function, I want to say something which I have been saying in this course. Like I said that in writing code, that using a delay function is not the best practice. The reason why I say that is that if you want to do multiple things, which in programming terms we call it multitasking, that means doing multiple things at a time, and you know that Arduino cannot do multiple things at a time. It only handles one instruction per time. So what if we want to do different things with different time rates? Want to do different thing, and using a delay function, just for like example, that we want to blink two LEDs at different time interval, and using delay function is not the best practice, because whenever we use a delay function, what delay function will do is that it will pause the whole program, after which that time is being after we have reached that time, it will now perform the next task. So whenever you are using a delay function in your program, what it does is that it will pause the whole program. That means you can't do multiple things at the same time. Okay, so but we have another way of doing multitasking, or doing multiple things at the same time. Okay, so let me quickly show you something here. I want to specify something here. I want to talk about delay microseconds, which is this one now. Okay, so let me uncomment it so that you see how it looks like. This is delay microseconds. So this delay microseconds is that whenever you call this function, it will delay for microseconds. Remember, dealing with normal delay, the delay this normal delay function delays for in millis. So whenever you're using this delay, that means you are delaying in millis. But if you want to delay in microseconds, you use this delay function. And bear you in mind that, see the syntax of writing this function. Remember this micro here, this starts with a capital letter, a capital M. So mind the cases, so that this thing will turn to normal color. If not, it won't change. It will change to normal color. Okay, so whenever you want to delay in microseconds, you use this delay microseconds. But whenever you want to delay in millis, you use your normal delay. Okay, and I say that using delay will pause a certain thing, will pause your program for a certain time, then after which that time has reached, it will continue. Okay, so let me comment this thing back so that I will show you what I mean by this topic that I'm discussing about millis, how we can use millis to perform multiple tasks without using delay function. Okay, so first of all, let's go to our global variable where we declare the LEDs. So this is the green, yellow, red. Okay, we'll still talk about this button. This button is specified for this topic today of using millis. Okay, so we have declared a global variable which we set the pins of our LED 13, 12, 11. So this is the global variable. Then we go to our normal setup, to declare those pins as an output. Okay, so now I want to show you something before going to the millis. See, look at this line of code. I want to turn on this green LED high, then delay it for 500 milliseconds, then turn it off, then delay for 500 milliseconds and turn the yellow LED on. Okay, I will turn this yellow LED on, then after some 500 milliseconds I will turn off the yellow LED, then after 500 milliseconds I will turn on the red LED. Okay, so see, if you see the way this code is being arranged, you see that after this compiler execute this line of code, this one, it will wait, it will pause this code. But my aim of this writing this code is to for these LEDs to turn on at different time interval, okay, to be turning on the same time. If the green LED is turning on, the yellow LED is turning on, the red LED is turning on. I don't mean that they are going to turn on at the center. What I mean is that if the green LED is blinking, because what I did here is just a blinking sketch. This is just a line of blinking code, which means that the green one will on and off. So likewise I did for the yellow. So I want the green light and the green LED to be blinking. The same time, let the yellow LED to be blinking. Okay. So I'm going to show you. Go to our Pro Tools simulator and show you this line of code that I just write here. Okay. So remember, our aim is that we want the green LED to be blinking, and also in the same time for the yellow LED to be blinking and the red LED to be blinking at the same time. Not that all of them will be on at once and off at once. We don't want we don't want the green, the yellow and the red to turn on at the same time and then turn off at the same time. What we want to do is for them to blink at the same time. That means if the green LED is blinking, also the same time the yellow LED is blinking. Okay, that is this line of code here. So and I'm using the delay function. So let's see the difference between using that delay function and the effect the delay function causes in our program whenever we want to do multitasking. Okay, so let me just go to our Pro Tools simulator and show you this thing that I just wrote here. So guys, we are in our Pro Tools simulator. So I'm going to simulate this thing now, so that these three LED, the green, the yellow and the red LED will be blinking at the same time. So I'm using the delay function. So let's see the effect of this delay function. So let me simulate the whole thing. So let's watch and see why this thing is simulating. Okay, so you can see that the green LED is on now. Then you see it is on and it has not turned off. Okay, but our aim is for it to be blinking, but it's not blinking. So it is on for it is on for 500 milliseconds, then off for 500 milliseconds. Then the yellow LED will now turn on, and this yellow LED will be on for 500 milliseconds. After 500 milliseconds, it will turn off. Then still wait for 500 milliseconds before the red LED turns on. Just watch what is happening here. You see that the red now is now on. But that is not our aim. Our aim is for them to be blinking at the same time. Blinking is different from turning on. Assuming that I want to turn all of them on, that means I will set all of them to be high, then use a delay and set all of them off at the same time, which means that the three of them will be on at the same time. After some seconds, it will turn off for some at the same time. But that is not our aim. Okay, you see what the delay function is causing in this code, which means that it is holding the whole code. So you cannot execute multiple things at the same time using the delay function. So let's go to our Arduino IDE, where I will be introducing the milliseconds, where we can blink these three LED at the same time using the milliseconds. So we are in our Arduino IDE. So what I'm going to do is that I'm going to comment this thing out. Okay, this delay function, I'm going to comment it out so that I can introduce the milliseconds. Okay, so let me comment all these things out, then we'll talk about the milliseconds. So this is the milliseconds. This is it. See the syntax of writing milliseconds. Okay, this is millis function. Sorry, this is millis function. These functions will allow us to do multiple things at the same time. Okay, so but before I talk about these milliseconds now, let me try to explain how this milliseconds works. Whenever you call this millis function, please, my mistake is not milliseconds, it's millis function. Whenever you call this millis function, the work of this millis function is that it will, whenever you on your Arduino, this millis function will start counting the time that the Arduino started running. Okay, so whenever you plug in your Arduino Uno or your microcontroller, Arduino Uno, whenever you plug in your Arduino, whenever you power your Arduino Uno, and you call this millis function. This millis function will start counting the time that this Arduino Uno started running. Okay, that is the work of this millis function. So how do we use this millis function to deceive the Arduino board that we want to do multitasking? Since Arduino board can only do one instruction at a time, how do we use this millis function to confuse the Arduino board? That is what I'm going to show you here. So first of all, we will declare. So we have declared our global variable. Okay, then before you start using this millis function, there is a couple of variable that you need to declare outside as a global. Okay, and which I'm going to explain in this video. First of all, let me uncomment all these things that I just comment. Here, this is we declare a global variable using unsigned long. This is a data type, unsigned long, and you know this millis function can count up to 4 billion. This millis function can count, once your Arduino is powered on, this millis function can count up to 4 billion. And counting that up to 4 billion, we need a large space to store that information. And if we look at our data type, let's go to our data type size capacity. Okay, if you look, these are the data type we have. You can see their sizes and the value that they can store. If you say we want to use a character data type, it can store up to 4 billion something. You can see the range that this character type, the value it can store. If we decide to use an integer, this integer can only store minus 32,768,000 to 32,767,000. And if we decide to use long, this long data type here, this long data type can store all from minus 2 billion and something. Okay, and you know this millis function only counts only positive number. It can't count a negative number. Okay, so we can use this long data type. All we need to do is to use this unsigned long, and this unsigned long, you can see it can store from 0 to 4 billion something, which the millis function can count up to. So that is the space that we need. We can use any other data type function. We can use any other data type to store that our value, because we need a large space, and the only data type that can provide us that large space is this unsigned long. That's why whenever you are using a millis function, you must declare it using unsigned long. Okay, so let's go to our Arduino IDE. So because we want to store a large number, because this millis function can count up to 4 billion, so we need to declare a variable that will hold those values that this millis function will count on. That is why we declare this variable using the unsigned long. We declare previous LED. This G means the green LED, the yellow LED, and the red LED. So this variable that we declare here is where we are going to be storing the information, the count that this millis function will count on. Okay, that is why we declare this unsigned long. You can see this one is for the green LED, this one is for the yellow LED, this one is for the red, and we set this variable to 0. That means at initial time it is 0. Okay, then we now use a long interval. This value that you see here is just like a value that you put in your delay. Whenever you want to delay for 300 milliseconds or 1000 seconds, this is what we do. We use a long, because you know we are dealing with a long value. Because the value that we are the function that we are dealing counts high. Okay, so that means we have to use a long int. I just named my this thing interval. This interval means the amount of delay that it will hold. So whenever you see this thing, I'm specifying the time of the delay it will hold. That is the work of this thing. So interval 1, interval 2, interval 3 will hold the delay function for the LED, green LED, yellow LED, and the red LED. So that is the work of this interval. Okay, so I want to take my time to explain these things so that you understand it. That is why I'm delaying all these things. I want you to understand each bit of this code. So just like our delay function that you set your delay, set the amount you want it to delay. That is what we are doing here. Remember, we are not using the delay function because we want to do multitasking. Okay, so we use this variable here to just store the amount of time we want that our LED to delay. So this is the amount of time we want it to delay. So I'm using a long data type, which also have a large space too for this interval. Okay, that is why I use this long data type. So this is interval 1, interval 2, interval 3 with different time delay, with different time that we want it to delay. Okay, so that is it. Then we now go to our setup and set our LED to output and all those things, blah blah blah. Then we now come to this millis. Now we want to call this millis function. So in order to call this millis function, I need to create a local variable. Okay, if you like, you can create a local variable if you don't, but it's very, very important you create a local variable because you need to specify the space. Okay, you need to specify the space. That is why I'm creating a local variable. That is why I want to store that millis inside a variable. I now declared unsigned long. That means a large space, because this millis function can count up to 4 billion. So I now created that space that will accommodate that count. Then I now call the millis. I now name my variable current time. The current time means the time it is counting. That is why I'm naming this. You can name it anything you want, but this is the one I name my variable, that which I want to store this millis function into. Okay, remember the count that this millis function will be counting will be stored in this current time, this variable here. So you can see that I initialize this millis function inside this variable. Then what will happen is that we will give it a condition. We now say if current time, that means which is our millis. So remember, if I call this current time, that is referring to this millis. That means this millis is like it is here. And I say if current time minus our previous LED, which is the green one. The previous means I'm using this variable to hold the position. Okay, I'm using this variable to store the counts. And I say if the current time, remember this previous LED, the green previous LED G is 0. This is 0. And I say if current time minus this previous LED G is greater than or equals to interval 1, and this interval 1 means what? This is 300. That means we are saying if the after minusing the current time with this previous time, and if it is still greater than 300, remember this interval 1 is 300. Let me show you what happened here. Is that, for example, whenever we power this Arduino will start counting, and you know the counting of Arduino is very, very fast. So if this current time, that means this millis is maybe like is counting like it has count up to 200 counts, or maybe let's say 500 counts. We now say 500 count minus 0, because this previous LED G is 0 at initial time, so it's 0. So if you say 500 minus 0, that means it's still 500. And we now say 500 if 500 is greater than or equal to 300. So what is our interval 1 value? Our interval 1 value is 300. We now say if this 500 is greater than or equal to interval, which means the 500 is greater than 300, that means it has made this condition true. And since it has made this condition true, our Arduino will now execute the code inside this if statement. And what is the code inside this if statement is that the previous LED G equals to current time. What we do is that this current time, which is 500, will be stored in this previous LED G. It will no longer be 0 again. It will now store the 500 count that our current time is counting. It will now store it in this variable. Okay, it will now store it in this variable. Remember, if you don't want to change any variable value, value, you declare it with constant. So let me show you what constant looks like. Let me use this thing now. For example, I will say const. You can see the value. You can see the color has changed. Whenever you use this thing here, you cannot change the value. You cannot. If I put this thing here, that means this thing cannot be able to count. It can't be changing. If initially this millis is 0, you can that value cannot be updated, because I said that the value that is inside this variable must be constant. That is the essence of using constant. So if I try to compile this, I will get an error. So whenever you don't want to change any value of any variable, you use this constant here. So if I don't want to change the value of this previous LED, that I want it to still remain at 0, I'll put constant in that variable. That means I'll put constant here. It can't change this 0. But I want to be changing the value that is being stored in this variable. So that is the reason we don't use constant. So the reason I'm pointing this thing out is so that whenever you see this constant in any code, so that you know the reason why it is there. Whenever you use constant, that means you don't want to change the value inside that variable. So what will happen is that if this our current time is 500, then this 500 will now be stored in that our previous LEDG. That means this our LEDG will not be 0 again. It will now be 500. Then it will now execute. It will now write digital write LED. This is the pin, which is pin 13 for the green LED. Then this LED state is this variable that I just declared here. This state is that I want to invert it. And I declare the variable integer LED state, the state of the LED. Instead of me to writing high and low, I just use a variable to be putting the LED in a different state. Okay, so just see that this state now, this LED state is the state that I want the LED to be in, and I set it to 0. The LED state for the yellow, I set it 1. Then for the red, I set it 0. I have a reason for that. So then what will happen in this code is that this LED state, I will not invert that value. That 0 will not be inverted to 1. Okay, and you know that this LED state is 0. That means the LED will be off. Then whenever this thing recycle again, it will not invert it. This LED state now is 0. After which it has executed this thing. That means putting the LED to low state. Then it will now come here and now invert that LED back to 1. That is why we use the Boolean operator here. This is the Boolean operator, the inverting and Boolean operator, which is the OR gate. Okay, so this is the Boolean operator which we use to invert the value. This LED state, which is 0, we now invert it to 1. So whenever this thing recycle again, it will come here and see 1 here instead of 0, because that is the reason why it is being, that is the reason it is blinking, because at each cycle it repeats itself. It will be seeing different state. If this thing is 0 state, whenever the compiler recycle again, it will see it as 1. Okay, I hope you understand it. If this one is 0, after which it has gotten to this line of code, it will invert it using the Boolean operator to invert it to 1. Then when this compiler starts over again, it will see 1 here. After executing it, after turning this green LED on, this operator here will now invert it back to 0 again. That is how it is blinking. So this is what happened to this. This one is for the green, this one is for the green, this one is for the yellow, while this one is for the red. Okay, and it is also the same thing. It is still the same thing. In this yellow LED, what I did is that the current time, if the current time is still 500, you minus the 500 from the previous LED Y, which is still 0. And if 500 is greater than interval 2, so what is interval 2? Interval 2 is 200, which means the 500 is greater than 200. It will execute it will on the yellow LED, okay, using the LED state, and also invert it. This is for the yellow and this is for the red. Okay, so let me remove this thing here. I'm going to compile it so you see how these LED are blinking at the same time without using a delay function. Okay, so let me compile it and see and show you how it works. So we are in our Proto simulator. So I'm going to simulate it so you see what I mean by blinking these three LED at the same time with different time interval. Okay, let me simulate and let's watch why it starts simulating. Okay, so let's wait while my system is lagging. That is why you are seeing this a little bit delay, because of my system is lagging. So you can see how these three LEDs blinking at the same time. Okay, the yellow LED will blink, the red will blink, the green will blink. So don't mind the lagging, is because of my system. But if you are using your own, if your own system is more faster than my own, you will see how fast this will be. Okay, so if you are using the same code that I'm using, you see how fast this thing will be. So this is how to use a millis function to do multiple things at the same time. Okay, so that is it about this example. Then another example that I'm going to show you is using this push button. So I want this, the next example is that I want this green LED to be blinking. Then at the same time, whenever I press any button, maybe if I press this button now, this first button, it will turn the yellow LED on. If I press this one, it will turn the red LED on. That means this green LED will still be blinking while I'm doing all those things. And if I use the delay function, it won't occur like that. Okay, but I'm not using a delay function, I'm using millis function, which allow me to do multiple things at the same time. So that is what I'm going to do now in our code. So let me go to our Arduino IDE and explain that line of code of how to achieve and this thing, blinking the green LED, and also you can use this push button to turn this yellow and red LED. So now what happens is that I have commented this the yellow and the red LED blinking. Okay, I've commented them out. Then I now introduce the if statement, so that whenever I press the push button, whenever the push button is low, it will turn on the yellow LED, and if the button is not pushed, it will turn it off. Likewise the red LED. So that is the work of this if else statement that I use here. So this one, this if else statement is for the yellow one, the yellow LED. Whenever the button is pressed, it will turn the yellow LED on, and whenever it is not pressed, it will be off. Why this one is for the red LED. So I want this blinking LED for the green LED to be blinking. Why? Whenever I press any push button, it will turn other LED on. So let me compile it and show you how it works. Okay, so this is it. I've run the code, so let me simulate it so you see what happens here. Okay, let's wait while the system simulates. Even though my system is lagging, we'll wait while it starts simulating. Okay, so let's wait while the LED will start blinking. So you can see that the green LED is blinking. Okay, if you look at the system, you see that the green LED is blinking, and at the same time I can turn on this yellow LED while the green LED is blinking, both the red LED. Okay, so while it is blinking, I can do multiple things. That means this LED, the red one can be on, the green one and the yellow one can be on, while this green LED is still blinking. So that is the work of millis function. So this millis function will allow me to be doing multiple things at the same time. Okay, so I can turn off anything while other things have been working. So that is how to use millis function. So thank you guys for watching. I hope you learned something new. So see you in our next video. Bye.